Hi Year 11 Mathematics Advanced students. Today we are continuing on with the topic of Introduction to Calculus, and we're looking at the derivatives and indices. So last lesson we learned how to differentiate using short methods of differentiation. So we're going to use these same short methods to derive functions that have negative or fractional indices when we convert the fraction to a power of x first. So last lesson we learned that the derivative is the gradient function, which is used to find the gradient at any point on a curve. So we are going to use the exact same process. So we need to remember if f of x equals x to the power of n, then f dash of x equals nx to the power of n plus 1. So what we're going to do first is move this function so that it is converted to a power of x first. So we have f of x equals, remember that the square root is x to the power of a half. And then we are going to derive this. So we have f dash x equals, and we bring our power down, so it will be a half times our x to the power of our a half minus 1. So when we do this, we get f dash x equals a half times x to the power of negative a half, where x to the power of negative a half, we need to recall that a negative fraction is 1 over our x to the power. So it's going to be f dash x equals a half times 1 over x to our power of a half. So this is going to equal f dash x equals, multiply our tops by our bottom, so 1 times 1 is 1, over 2 times x to the power of a half is the same as root x. So that's how we differentiate our function. So just to note over here what we used, so if f of x equals x to the power of n, then f dash x equals nx to the power of n minus 1. Also, we have that the square root of x is equal to x to the power of a half. We have that the cube root of x is equal to x to the power of a third. And we have that n root x is equal to x to the power of 1 on n. And finally, we have that a to the power of negative m equals 1 over a to the power of m. So that's what we use to help us out with that question. Moving on to example 2, we have to find the gradient function for y equals 5 cube root x. So what we're going to do is we're going to break the function up. So it's going to be y equals 5 times the cube root of x. And then we want to find out, we want to convert the function to a power of x. So it'll be y equals 5 times, the cube root of x is x to the power of a third. Okay, so that's then the same as, oops, that's too big, 5 x to the power of a third. So we'll just get rid of the multiplication sign there. So then when we differentiate this, remember we can either write it as dy on dx, as we are finding the derivative of y with respect to x, or we can write it as y dash as well. So if we were writing it as y dash, it equals 5 times, which is our constant. We need to bring our power down, so a third times our x to the power of a third minus 1. So then we have y dash equals 5 times a third is 5 over 3 times x to the power of negative 2/3. So then we have y dash equals 5 over 3 times 1 over x to the power of 2 over 3. So that was using our rule up here, our negative indice rule. So then I'm going to just go down. So y dash equals, we multiply our tops together and our bottoms. So 5 over 3. And then remember, also that n root x to the power of m equals xm on n. So this means that so that means that our x to the power of 2/3 converts to be the cubed root of x squared as our answer. Okay, so that is our answer. So we found the gradient function for y equals 5 cube root of x. Then for question 3, we want to find the derivative of y equals 4 on x squared at the point where x equals 2. So we need to convert the function to a power of x first, and we want to get rid of the denominator. So we're going to write it as y equals 4 x to the power of -2. So because we have x 4 over x squared, we can write this as a negative indice. And then we want to differentiate. So either dy on dx, which is the derivative of y with respect to x, equals y dash. Also, if you want to write it shorthand. So when we differentiate that, we have our coefficient of 4 times our power of -2 times our x to the power of -2 minus 1. So then our y dash, or our derivative with respect of y with respect to x, is 4 times -2 is -8 times x to the power of -3. And remember, we want to get this back to how we found it. So we don't want to leave it here as -8x to the power of -3. So we want to bring this back to how we found it. So it was be y dash equals -8 over x to the power of 3. So then we want to sub in where, we haven't finished the question yet. We want to find the derivative at the point where x equals 2. So we need to substitute 2 into our derivative function. So it will be y dash of 2 equals -8 over our 2 cubed, which equals -8 over 8, which equals -1. So the gradient of the tangent to the curve at x equals 2 is -1, or we write, therefore, the derivative at x equals 2 is -1. Now remember to do your concluding statement to say what is going on at the end. And so, like I just said, you could also write or the gradient of the tangent to the curve at x equals 2 is -1.